Good morning. Thank you, all of you, for coming here, even though it's a long weekend. Today, I'm going to talk to you about enduring difficulties, women in science. First, I'll just introduce myself. I'm a professor at the Jawaharlal Nehru Centre for Advanced Scientific Research, which is an institute in Bangalore, in Jakkur. How many of you have heard of this institute? Okay, some have, some haven't. And I really think it should be better known than it is, because what I've put here is, I don't know if you've heard of the journal Nature. It is the most prestigious journal in science. And 4 years ago, what they did was they ranked institutions worldwide by how good they were, judged by their scientific productivity, and they normalized it by size. That is, they accounted for the fact that if you're a smaller institution, you will produce less, etc. And when they did that, our institute came 7th in the world. We didn't expect that either, but we were very happy to see that. And if you look, you see Princeton is 10th and Stanford is 11th. And so we were really very happy, not happy to be better than Princeton and Stanford, but we were, it's still nice to be in the top 10. I'm not going to talk much about my research today, but I just want to give you a flavor for what I do. So I do calculations on the computer or with my students, my PhD students. So what these 4 animations show you is we've studied how very small particles move on surfaces. So for example, here, the magenta colored spheres are platinum atoms, and the red and gray are magnesium oxide. And we're studying how very small platinum particles move on the surface of magnesium oxide. I won't talk about why this is important, but it is. And it turns out they move differently depending on whether there's 1 atom, 2 atoms, 3 atoms, or 4 atoms in the particle. So if it's just 1 atom, it hops. If it's 2, it does this funny cartwheeling motion. If it's 3, it does this, what I call at walking. I don't know, do you recognize what that at walker is? Do you know where it's from? Yeah, it's from Star Wars. As soon as my student showed me this, how it moves, I said, I know, something moves like that. And then I realized it's from Star Wars. And if it has 4, it rolls. So this was a very unexpected finding. Another thing we did, this is now not platinum, but gold nanoparticles. And when you put them on surfaces, they clump up into these 3-dimensional shapes. And we showed how if you replace some of these gray magnesium atoms in the surface by these purple aluminum atoms, you can change the shape of a nanoparticle. So this was a theoretical prediction that we made. And the picture there is of my student Nisha. And if you look closely, you will see her earrings. One is the 3-dimensional shape, one is the 2-dimensional shape. And after we did this, the next slide, please. Somebody did the experiment. And on the left, you see gold particles on the what's called the undoped surface. And this is done with a remarkable instrument called the scanning tunneling microscope. And on the left, you see these 3-dimensional shapes. And then when you dope the surface, on the right, you see these flat pancake or chapati-like shapes. So we made a theoretical prediction. And then when they did the experiment, they found that it works. So this is the power of the techniques that we use. So now I'm going to change tracks and not talk about this, my research anymore. So what is enduring? Enduring has 2 different meanings. And I think both are relevant to what I'm going to talk about. One is that if you're enduring something, it means you're holding up under something that's difficult and painful. You're surviving somehow. But it also means something that lasts for a long time. And I'm going to talk about both aspects of this word. So it's kind of a double meaning in my title when I say enduring difficulties. So endurance, I think, is an essential quality for a successful scientist. And then it becomes even more important if one is a minority in science. And there can be different kinds of minorities in science. You could be from a developing country, you could be a racial minority, you could be from a disadvantaged caste, or you could be a woman in science. And so this is a very famous picture. It's taken at what was called the Solvay Conference in 1927. And this picture is very famous. They sometimes call it the picture of the brightest minds ever, because nearly everybody in this picture went on to win a Nobel Prize. What you see in this picture is you see a bunch of physicists, mostly, a few chemists also, and you will see there'll be Einstein in the picture, Schrödinger, Dirac. These are all, if you're a physics student, you will know these names because these are amongst the most famous physicists. And you will see that there's just one woman in this whole group. Can you guess who that woman would be? Yeah, okay, because she's sort of the most famous woman scientist of all time, I think. And it's very noticeable that there's only one woman, okay? This is a quote from Madame Curie, and she says, life is not easy for any of us. But what of that? We must have perseverance. Okay, so perseverance is like endurance, and above all, confidence in ourselves. We must believe that we're gifted for something, and this thing must be attained. So why was life difficult for Madame Curie? Of course, she faced many struggles in her scientific research. I mean, she had financial difficulties. The work she did was very challenging. So scientific discovery requires endurance. If you say you start at that blue circle, it's not that you just go step by step by step and then you reach your result. I mean, usually you'll go in one of those top paths and then you don't find anything. You go another path, you don't find anything. You go another path, so you end up at those red crosses very often. And only after a lot of false starts, a lot of unsuccessful attempts, do you reach those successes of those green ticks. Okay, so most of the time you are stuck. Okay, and then you find something and you're very happy. And so for one day, maybe you're really happy, and then the next day, again, you continue and you're stuck again. So you really have to have a lot of endurance, a lot of patience, perseverance. This is a snakes and ladder game, but it's a rather unusual snake and ladder game. This was something one of my students, Garima, made at my suggestion, and it represents the path that we follow in our group when we solve a research problem. Okay, so some of the things that we do are very technical. You may not understand what it means if SCF convergence is achieved or not. But the point is, when we do it, there's a lot of successes and a lot of failures. And you see that, I mean, some of these are related to whether the research works or not. But for example, if you see in number 58, it says referee 2 hates your work. So when we do our science, we then submit it to a journal, and we obviously think our work is very good, and then it is sent to referees, and then the referee may say, you know, this is not interesting work, or this should not be published. And it's so frustrating. After all that work, you write it up, and then bang, you have to start all over again. So it is very frustrating. So you do need endurance. Another reason you need endurance is the way scientific career paths are structured. It takes an awfully long time to get one's first real job. So after your MSc, you start your PhD. So you start maybe when you're 22, and then it takes, say, somewhere between 5 to 8 or 9 years to get your PhD. Depends. In some fields it's quicker, in some fields it's longer. After that you do one postdoc, and then you do a second postdoc, and then hopefully after that you get a faculty position. So you're maybe around 33, 34 when you start looking for your permanent job. And if you're lucky, you get it. But if you're unlucky, you still have to do a few more postdocs before you get your job. And then there's the additional pressure that for a lot of jobs, they say you have to be under 35 to get it. But still, you're about 35 when you're starting to look for a permanent job. And that's kind of old compared to many other fields. And so families will be telling you, what is this? How long are you going to study? When will you get a real job? There's a lot of pressure, saying, stop this, just get a job. So you need endurance in that respect also. Next slide, please. For Marie Curie, many people, I think, know the story of how she had to really struggle when she discovered polonium and radium in radioactive, which are radioactive elements. So the point is, to discover them, she had to go through, they're present in really small amounts, trace elements. So she and her husband, Pierre Curie, they had 1 ton of this mineral called pitchblende. And from that, they were finally able to isolate 1/10 of a gram of pitchblende. So that's obviously something that takes years and a lot of hard work. And this is something I was taught about even in school. Okay, the struggles they had, and they didn't have a proper lab, they had to do it in a shed, all this. But we don't hear so much about her struggles as a woman. She has said here, I have frequently been questioned, especially by women, about how I could reconcile family life with a scientific career, and it has not been easy. She says, I have a great deal of work with the housekeeping, the children, the teaching, and the laboratory, and I don't know how I shall manage it all. This is from a letter she wrote to her brother. So, I mean, okay, here she was, the most famous woman scientist of all time. And she still had to do the housekeeping. She still had to look after her children. So this is a picture of her with her 2 daughters, okay? So she had to worry about these things. She faced a lot of hostility, even though she was such a brilliant scientist, okay? So after her husband died in an accident, and then she continued her work alone. And then at some point, there were rumors that she was having an affair with this other scientist called Langevin. And then she was really attacked in the press. And he was not attacked, only she was attacked. And the attack said that she was spoiling the memory of her dead husband. Okay, and so this thing on the right is an attack on her in a French newspaper. You see they sort of printed a very terrible picture of her and trying to make her out to be a criminal. And they said she's a foreigner. They also said she was Jewish. I mean, actually she wasn't Jewish, not that that matters, but that was part of the attack on her. And they felt she should be hounded out of the country, should not be given any honors. So in France, there's something called the French Academy, which is, if you're a French scientist or academician of some kind, that's the highest honor. And it's a very great honor because the number of people who can be a member of the academy is fixed. So you can only become a member if somebody who's already there dies. Okay, and people proposed to elect her, and she was not elected because of what was considered her dubious morality. Okay, and she was, you have to remember, she was the first person to win 2 Nobel Prizes, and still she was not elected. And there were protests outside her house saying that she was a bad woman, etc. And then when she won her 2nd Nobel Prize, the people in Sweden who were awarding the Nobel Prize told her that maybe she shouldn't come and collect the prize because of her bad character. So what's it like in India? This is a little bit later. So this is someone called Kamla Soni, who some of you may have heard of, but I suspect most of you won't know her. My mother knew her personally. She was an Indian biochemist, and it seems like she was the first Indian woman to get a PhD in any branch of science in India. There are other people who say they were the first, so it's not very clear. She was a student of C.V. Raman's, but he refused to admit her to IISc, Indian Institute of Science, because she was a woman, and she staged a satyagraha outside his office demanding to be admitted, and finally he relented and he admitted her, but on various conditions, like she should promise not to distract the male students, she shouldn't talk to the male students, things like that. She did some very important work. She worked sort of in nutrition, and she did studies on proteins in milk, dal. She discovered an enzyme called cytochrome C. So this is what she said. She said, though Raman was a great scientist, he was very narrow-minded. I can never forget the way he treated me just because I was a woman. He didn't admit me as a regular student. This was a great insult to me. The bias against women was so bad at that time. What can one expect if even a Nobel laureate behaves in this way? How is it today? You can say, okay, all this was like, 50 years ago, 100 years ago. So this is Soumya Swaminathan, whom many of you may know about. She was the chief scientist of the World Health Organization, and she says, it was only after I started my career in a government research institution that I experienced the culture of a male-dominated committee room. That's when you felt you were being talked down to or made fun of almost. I was not taken seriously. I was always told what to do, and if I had ideas, they would be shot down. Okay, and she says many of our institutions are very patriarchal. So let me tell you about two recent stories about women in science and what they faced. Okay, so this is Donna Strickland, who won the Nobel Prize in Physics in 2018. She was only the third woman ever to win the Nobel Prize in Physics. The first was Marie Curie, the second was Maria Geppert-Mayer, and then she won it in 2018. So in October 2018, she won the Nobel Prize in Physics. In March 2018, somebody tried, so a few months before this, someone wanted to make a Wikipedia page on her. Up to then, she didn't have a Wikipedia page. And then in May 2018, the Wikipedia page was taken down, permission was not given, because they said she didn't qualify for one. She was not important enough. Okay? She also wasn't a full professor in her own university. She was what's called an associate professor. And then in 2018, October, she won the Nobel Prize. And then suddenly, okay, she, her university is proud of her. They make her a full professor. They start giving her all kinds of honors. Obviously, she gets a Wikipedia page. Okay? And then the next person I want to talk about is Kathleen Carrico. She won it last month, the Nobel Prize in physiology and medicine. But if you see what she had to go through, she was unable to obtain funding for much of her career. Because of that, she was demoted. She was not given tenure, and she was told that she was not of faculty quality. That's why she wasn't given tenure. Also, the paper on the work for which she was given the Nobel Prize, she submitted it to Nature, and it was desk rejected. That means the editor did not even send it out for refereeing, did not send it out for reviewing. Okay? And now, of course, the university is very proud and says, oh, our university got the Nobel Prize. So, I mean, these are women who've been as successful as it's possible to be, in the sense that they've got Nobel Prizes. But if they are suffering so much, you can wonder what other women in science, how they're treated, how they suffer. So what are the things they have to endure? They're few, they're pressures due to family responsibilities, there's discrimination and bias, which can be explicit or implicit, isolation, lack of peer group and mentorship, hostile work environment, sexual harassment, lack of recognition. I'll try to go through some of these very quickly. So I like this cartoon very much because it tells you what is the additional things a woman has to endure in order to succeed. I mean, it's like you're running a race. Everybody has to run this race. Men have to run the race too. But if you're a woman, there are all these additional obstacles that you have to face to succeed. So here are just some statistics. This is a map of the world, and it's colored according to what percentage of scientists in that country are women. And the darker the color, the greater the percentage. And in some countries, it's almost half are women, but in most countries, it's not. If you look at the whole world, 28.8% of scientists are women. But you'll be surprised. I mean, we all have our biases, okay? We think in some countries it's high, some countries it's low. But if you look at Central Asia, it's 48.1%, okay? If you look at the Middle East, it's 39.8%, which is higher than in North America and Western Europe. And then if you look at Sub-Saharan Africa, it's about the same as in North America. Okay, and our part of the world is where it's lowest, which is South and West Asia. And then how does India do? This is percentages for countries in Asia. We have 13.9%, which is the second lowest in Asia. Only Nepal is lower than us. And Bangladesh, Pakistan, Sri Lanka, all have higher percentages than us. I was very shocked when I saw this. I hadn't realized that. So this is the percentages in India in various fields. So biology has 25.5% women, and then other math has 15.8%, then other fields all have about 10 to 15%. Okay? This is from a site called Bias Watch India, which keeps monitors bias in academia, in science in India. And this is data from sort of 97 leading institutions in India. So why do we have so few women? So if you look at the statistics in India, if you look at science PhDs, almost half of science PhDs go to women. But then if you look at working scientists, it's only about 14%. So that means that something is happening after the PhD. We're losing women after the PhD. So what happens? I mean, it's not very clear yet, but it seems like, okay, first of all, after PhD, women get married. And then there's a lot of family pressure to not work in science anymore. And the other thing is maybe there's discrimination in hiring. So if you look at women working in science now, about a quarter of them have had to take a break in their educational career. So if you ask them why, then the leading reason they dropped out is family care. Then the next reason is location shift. They had to move. And that also is usually related to getting married. They have to move. And this survey that I'm showing you was done of women who stayed in science. They took a break and then came back. It's not the women who dropped out. So there are lots of women who just dropped out. This is an interesting study that was done throughout the world. It had about 32,000 scientists were surveyed, and they asked them, did becoming a parent affect your career in science? And the green bars are women, the men are the orange bars. So you see much higher percentage of women say it affected their career than men do. And then what about things like housework, cleaning, cooking, things like that? So this was a survey of about 15,000 physicists, and it asked them, who does the majority of the housework in your family? And in less developed countries, 40% of women said, I do, and 8% of men said, I do. And if you look at the highly developed countries, it's not very different. 33% of the women said, I do, and 8% of men said, I do. This is working physicists who were asked. Okay, so if you're a physicist and you have to do also most of the housework, clearly this is going to impact your career. So another thing is what's called the two-body problem, which is if you see women in science, most of them are married to a scientist, whereas most men in science are not married to a scientist, just because maybe there are not enough women to go around. And then you have that problem of you have to find two jobs in the same place, same institution. And that's very hard, okay? I mean, it's hard in general, but also many institutions have policies that they will not hire couples. So then you have what's called the two-body problem. And this was a survey in different countries where men and women were asked if this two-body problem had affected them. And the green bars are men and the blue bars are women. And in most places you see women say it was a real problem for them, much more than men do. Next slide. I told you that papers are refereed. Okay, somebody says whether your work should be published or not. Another time you have refereeing is funding. Somebody looks at your CV and your proposal and decides whether you should be given funding or not. So this was a study done in Sweden. So that graph, if you're not used to reading graphs, let me try to explain to you. On the x-axis, on the horizontal axis, people have tried to be objectively see how good somebody is by looking at things like where they studied, how much they published, where did they publish, how many papers they published. And on the y-axis, it says what was the score that the people who were refereeing the proposal, who were reviewing the proposal, gave them. And you see across the board, men were given much higher scores than women who had exactly the same qualifications. Okay? And they said women had to perform 2.5 times as well to get the same score as men. So if to just be evaluate, if you had to be 2.5 times as good as a man to be judged as competent, that's like a huge extra burden on women. So you not only have to do all this extra housework and family care and everything, but you have to be much, much better than the men to be told you're as good. There's something called implicit bias, which is that, so why does this bias come? So some people, of course, think explicitly, oh, women can't do science, women are not good. But what is much more common is it's a bias that we don't even know we have. So there's this online test you can take to see if you have this implicit bias or not. It just takes about 5 minutes, so all of you can do this test and see. The first time I took the test, I was completely horrified by my results. It said I strongly associate men with doing science and women with doing arts. Okay? My score has changed since then. I don't know if that means the implicit bias is gone or whether I've learned how to cheat on the test. I don't know. And why do we have these implicit biases? It's because, everywhere we are given these images, okay? Like this is from some primary school textbook, okay? Jobs. The only job the woman is doing is school teacher. All the other jobs are done by men, okay? There's sexual harassment, which is widely prevalent. I'm not going to talk too much about it, but this is that same survey of 32,000 people in different fields. The green bars are women, the orange bars are men. And everywhere you see 30 to 39% of women are saying they personally experience sexual harassment. There is a very small percentage of men who have also experienced it, which I think is interesting. But of course, the percentage of men is much smaller than women. I asked you, do you think it has happened, that things have changed since that picture of Marie Curie at the Solvay conference? So this is a picture of me at a conference. Can you find me? I'm like there at the left, right at the back, when my hair was still black, okay? So, and you can see I'm surrounded by men, okay? Do you find anything strange about this poster? Look at the theme. It says women scientists into the center stage. And I mean, there are no women on this poster. It says key speaker, chief patron, chief guest, and they're all men. Okay? And they didn't even find anything strange about this. Okay? Now, there are some attempts to change things. Like, this was, 2016, okay? So, the IITs, NITs, etc., they have these board of governors, okay? And the ministry, the MHRD, can put 2 people on every board as their representative. And what they did in 2016 is they made all their representatives women. Okay, so these are the names of the people. My name you will see somewhere. So all of these representatives were women. So I was one of them. So suddenly all these boards, which used to be all male, had women representatives, and they would typically be the only women on this board, which I thought was progress of a sort, except then our terms ended. And then, they made new boards, and then there were again no women. I mean, maybe 1 or 2 women in some boards. So I checked, and again, you have all these IITs and NITs which have no women on their boards. So, you may make progress, but you also go backwards sometimes. I'm trying to say, is it changing? This is the percentage of men and women studying science. You see slightly, the percentage of women is going up, but very slightly. And, in the US, it's very interesting. The percentage of women doing computer science has steadily gone down. Because in the early years, computer science was seen as a woman's subject. Okay, because it was seen like sort of some kind of clerical job, you're typing in data, that kind of thing. But as computer science increased in prestige and the salaries you could get also increased, the percentage of women went down. People have tried to see when we will reach, at the rate of improvement, when will gender parity be reached. And for example, in physics, if we continue to improve at the current rate, they've said in 2156. Okay, it's not 2056, 2156. So clearly, I mean, things are not improving fast enough. One of the last things I want to tell you is a story of Jocelyn Bell Burnell, who someone I had the privilege to meet. So in 1967, she discovered pulsars, which is these pulsating radio sources. Okay, they're these astronomical objects. And she was a PhD student. She told her advisor. He didn't believe her, finally believed her. They wrote it up. Then the Nobel Prize was given. And of course, he got it. She didn't get it. But not only that, he apparently told many people that she's not a very good student. So she had trouble even getting a postdoc afterwards. Then she got married. Then she went around from place to place because her husband was in a transferable government job. And she told me she couldn't get often jobs as a scientist. She would get jobs as, managing the library or doing science outreach, those kind of jobs finally. But then, I mean, at some point, people began to realize that this was a great injustice that had been done, and they tried to correct it, and then she got a job at Oxford. And in 2018, she was awarded the Breakthrough Prize in Fundamental Physics, which I think is $3 million or something. So you can say, okay, I mean, she can't get the Nobel Prize, but at least she's acknowledged. But for example, I was there in a meeting in 2014 on women in science, where Sir Martin Rees, who was the Astronomer Royal and the president of the Royal Society, was asked, do you think it was an injustice that she wasn't given the Nobel Prize? And he said, I heard him say it myself, I don't really see why she should get the Nobel Prize. I mean, she wasn't really serious about physics. She was just following her husband around. And I thought that was a completely shocking answer. So what do I do about these things? I mean, they make me very angry. So, I mean, I do various things for trying to support women in science. One thing I've been doing is I've been conducting these what are called career development workshops for women in physics, which is at this International Centre for Theoretical Physics in Trieste in Italy. This is a very interesting institute which is meant to support physics in the developing world. We've also held it at an institute in Rwanda in Africa. So what do we do in these workshops? It's a space for women to share experiences, then also acquire skills to rise in their career, because I feel that men have this sort of boys network which helps them acquire skills, learn how to do things, learn which fellowship to apply for, which award to apply for, and women lack that. So we try to provide this network and a community that can support each other. There's a best-selling book right now which you might want to read. It's called Lessons in Chemistry. It was the #1 bestseller in the US and UK. It's a story, it's set a few years back, set in the 1950s in the US. It's about a woman who's a very brilliant chemist, but because of sexism, she gets fired from her job. And then the only job she can get is at a cooking school, a cooking show on TV to teach cooking. And she uses this cooking show to instead teach chemistry. Okay, so, I mean, I don't quite like the way the book is marketed. It is marketed as, what is called chick lit. Like you can see from the cover, right? They're making it like a light, frothy book. I actually found the book very disturbing. It made me very angry. But I still think it's an interesting book. It's not too heavy a read, not too light either. But you might want to read it to see some of the themes. People say to me, oh, you've been so successful. You've had such a good career. You won so many awards. Am I proud of it? In keeping with this theme of endurance, what I'm proud of is not so much I feel I succeeded, but that I survived. I didn't drop out. I managed to hang in there. I didn't quit. And so I endured, I guess. Thank you.